Hey guys, today we're going to be learning about conditional statements. A conditional statement is a sentence written in an if-then form, where the hypothesis is the if and the conclusion is the then. We'll also be learning about logic. Logic is the study of reasoning that consists of a hypothesis and a conclusion, and reasoning is drawing conclusions from facts, observations, and experiments. There are two types of reasoning. There's inductive reasoning, and there's deductive reasoning. Inductive reasoning is made from observations, while deductive reasoning is made from facts. Let's try these two practice problems before moving on. Try to figure out whether they're inductive reasoning or deductive reasoning. All dogs have ears. Goldie's a golden retriever, which means she has ears. Goldie is a golden retriever. We know that golden retriever is a type of dog. We also know that the statement, all dogs have ears, is a fact, since they're just giving it to us, and also by personal knowledge. We also know that deductive reasoning is based on facts. So let's read this problem again. All dogs have ears, which is a fact. Goldie's a golden retriever, which is a dog, which means she has ears. That is true, so it's a fact. It's deductive reasoning. Alright, the next one says, every time you pull your dog's tail, it bites you. You conclude that if you pull your dog's tail, it will bite you. Well, we know that every time we pull our dog's tail, it bites us. But that's not a given fact, it's what we observe, it's what we see. And since inductive reasoning is observing and seeing, it would be inductive reasoning. Alright, so in math, in order to prove something is true, you must not be able to prove it wrong, which makes sense, right? But if you do provide an example where it fails, you are providing a counterexample. All you need is one example to prove something is wrong. Alright, let's do some practice examples. All odd numbers are prime. Is there a counterexample for this? Well, there is, and one of them is 9. 9 is odd, but it's not prime since 3 times 3 equals 9. The other one says all shapes that are round are circles. Well, let's go to our trusty little shape. And ovals are round, but they're not circles. So our counterexample would be ovals. The next one says if x squared equals 16, then x equals 4. Not necessarily, because we've learned that negative times negative equals positive. So negative 4 equals x, because negative 4 times negative 4 equals 16. And negative 4 times negative 4 is just negative 4 squared. Moving on, we use conditional statements to help prove things are true or false. Going back to the beginning of the statement, I said if a sentence is written in an if-then statement, then the if is the hypothesis, and the then is the conclusion. Let's try and practice. If it is noon in New York, then it is 9 a.m. in California. We know that if goes with hypothesis and then goes with conclusion. So we're going to circle our hypothesis, which is it is noon in New York. Then it is 9 a.m. California. We know that then goes with the conclusion, so we'll underline our conclusion, which is it is 9 a.m. in California. A tip, do not include if/then when stating the hypothesis and conclusion. So let's do the other one. If it is your birthday, then you get to eat cake. It is your birthday is hypothesis, and then you get to eat cake is the conclusion. Okay, so now let's try writing statements as conditional statements. First one says an integer that ends in 0 is divisible by 5. We know that hypothesis goes with if and conclusion goes with then. So our answer would be if an integer ends in 0, then it is divisible by 5. The second one says I will go to the football game on Friday if my friends are going. So really what it's saying, and you have to think about it, is if my friends go, then I will go. So our answer would be, if my friends are going, then I will go to the football game on Friday. Or it could be, if my friends are going to the football game on Friday, then I will go. Third one says, people will think you are smart because you know how to use logic. Keyword here is because. Because you know how to use logic, people will think you're smart. So you're saying, if I know how to use logic, then people will think I am smart. So our answer would be, if you know how to use logic, then people will think you are smart. Alright, in order to prove conditional statements are true, we'll sometimes need to use/analyze converse, inverse, and contrapositive statements. If a conditional statement is true, then the contrapositive is always true too. So for the converse, we want to flip the hypothesis and conclusion. Right, flip the hypothesis and conclusion. For the inverse, we want to negate the hypothesis and conclusion. Hypothesis and conclusion. And for the contrapositive, we want to do both of those things. So we want to flip plus negate the hypothesis and conclusion. So this does take practice, but it's super easy once you learn. Alright, let's do our last couple of practice problems. So our statement is, if it is sunny outside, then I will wear my sunglasses. What is the inverse, converse, and contrapositive? So we know that converse is flipping them, inverse is negating them, and contrapositive is doing both of those things. And we know that it is sunny outside is the hypothesis, and I will wear my sunglasses is the conclusion, since we don't include the if and the then. So converse, we would flip those two things, and inverse, we would negate them. Contrapositive, we would do both. So converse would be, if I wear my sunglasses, then it is sunny outside. Inverse, we would negate them, so we would do, if it is not sunny outside, then I will not wear my sunglasses. And contrapositive would be, if I do not wear my sunglasses, then it is not sunny outside. Alright, the next one says, if two lines are parallel, then they never intersect. So the converse would be, if two lines never intersect, then they are parallel. Inverse would be, if two lines are not parallel, then they intersect. And the contrapositive would be, if two lines intersect, then they are not parallel. Alright guys, that is it on the basics of conditional statements. Thanks for watching, and as always, I'll catch you later. Bye!